Our bodies are run by this incredibly complicated communication network called the endocrine system. Think of it like a giant orchestra of hormones, controlling literally everything from your mood and energy levels to how you grow. But what if we could finally understand its language, crack its code? Well, that's exactly what's happening right now, where AI meets endocrinology, and we're about to dive in and see how. And believe it or not, that entire system is going through a massive revolution. We're seeing this fundamental shift in medicine, moving away from just, reacting to problems after they've already started. We're heading toward a future of what's being called augmented precision, where we can empower our doctors to be proactive. All right, so here's how we're going to break this all down. First, we'll get a handle on the body's super complex hormonal network. Then we'll talk about the data overload it creates. Next up, we'll see how AI is like a master pattern decoder, then look at it in action in a real clinic, and finally, we'll pull it all together to understand the future, the augmented doctor. So let's start with the system itself. The absolute best way to picture the endocrine system is to imagine a massive, intricate orchestra. You've got all these different instruments, hormones, glands, molecules, and they're all playing together in this incredibly delicate and dynamic balance. And here is the core challenge. This system isn't a simple math problem, where A plus B always equals C. No way. It's this complex web of feedback loops where everything affects everything else. A tiny change in one hormone can set off a whole chain reaction of unpredictable effects, and frankly, our brains just aren't wired to keep track of all of that at once. All of that complexity leads us straight to our next big problem. We are, and I mean this literally, drowning in a sea of biological data. And to really get the scale of this, it helps to think of it like an iceberg. This image just nails it. That little bit sticking out of the water, that's what a doctor traditionally gets to see. Things like your symptoms or your BMI. But underneath the surface, that's where the real story is. There is a vast, hidden world of data from our genes, from continuous glucose monitors, even from the trillions of bacteria living in our gut. So here's the bottom line. We've got all this amazing data pouring in from our smartwatches, our genetic tests, and our lifestyle choices. But it's too much. It has completely overwhelmed our ability to make sense of it. There is no single doctor, I don't care how brilliant they are, who can connect all of those dots on their own. And this is where artificial intelligence steps onto the stage. Now, let's be clear, we are not talking about some sci-fi robot doctor. Think of AI as the perfect tool designed for this exact job, finding the meaningful, hidden patterns inside all of that overwhelming noise and complexity. The best way to think of it is as a specialized toolbox, right? You wouldn't use a hammer for a tiny screw. It's the same idea here. You've got tools like machine learning, which is kind of like a student that learns by studying thousands of examples. Then you've got computer vision, which is trained to see things in images like a superpowered radiologist. And then there's unsupervised learning, and this one's really cool. It can take a giant, messy pile of data and find brand new groups and patterns all by itself. We'll see that in a minute. Now, one of the most powerful tools in this entire box is something called reinforcement learning. Just imagine learning to ride a bike. You try, you wobble a little, you correct yourself. The AI does pretty much the same thing, but millions of times, making tiny adjustments based on feedback, these reward signals to get better and better and better at whatever it's doing. Okay, that's enough of the theory. Let's get to the good stuff. How is this AI toolbox actually being used in hospitals and clinics today to help real people? Let's check out some pretty incredible examples. For decades, we've pretty much thought about diabetes as being in two big buckets. You have type 1, where the body just doesn't make enough insulin, and you have type 2, where the body can't use insulin properly. It's been a useful way to think about it, but it's also really, really simple. But AI lets us go so much deeper than that. It uses a technique called clustering, which is kind of like a digital sorting hat, to analyze all these different variables like BMI and insulin resistance. And you can see it right here in this graph. It automatically finds these distinct groups of patients, revealing these hidden subtypes that we used to just lump together as type 2. And remember that reinforcement learning we talked about? This is where it really shines, the artificial pancreas. This thing is an absolute game changer. You've got a sensor that's constantly checking glucose levels. It feeds that data to an AI, which is the brain, and that AI is then constantly adjusting an insulin pump. It's a nonstop, intelligent feedback loop. So how well does it work? Well, this system can predict a dangerous drop in blood sugar, what's called hypoglycemia, a full 30 to 60 minutes before it happens.
and it does it with an incredible 98.5% accuracy. See? We're moving from just reacting to actually predicting.
Okay, now let's switch gears to medical imaging. Take a look here. On the left is a pretty standard ultrasound of a thyroid nodule. But on the right, that's the AI augmented view. A deep learning model has looked at that same image and is now highlighting the areas it thinks are suspicious, seeing patterns that a human eye could easily miss. So what does that actually mean for patients? It means a huge drop in unnecessary procedures. This kind of tech helps cut down on the number of invasive and, let's be honest, pretty stressful thyroid biopsies by around 26%. And it does it without losing any accuracy. And if you think that's cool, it goes even a step further. We're now talking about a virtual biopsy. There's this whole field called radiomics, and it is fascinating. Think of it like a detective who can look at the grain of a photograph and find clues that nobody else sees. The AI is doing that, but with the pixels in a medical scan. It's analyzing texture patterns that are completely invisible to us. Now, there's a question that always comes up around this point. Does all this mean that AI is going to replace doctors? And the answer is a clear, resounding no. The future isn't about replacement. It's about a powerful partnership. A big hurdle for a long time was this black box problem. Early AI models would just give you an answer, but they couldn't tell you how they got it. For a doctor who's responsible for a patient's life, that's just not good enough. And that's why the whole field is shifting towards something called explainable AI, systems that can actually show their work. And this right here is the most important point of all. AI is a tool for crunching numbers. It can analyze more data in a second than a human could in a lifetime. But it can't replicate empathy. It can't understand a patient's personal values. It can't make a complex ethical call. That's where the human doctor is absolutely irreplaceable. So we arrive at this new model, the augmented endocrinologist. In this picture, the AI is not the one in charge. It's an incredibly sophisticated instrument, and it's in the doctor's hands. It decodes the complexity so the doctor can focus on what really matters, the person sitting in front of them. So when you put it all together, what does this human plus machine team actually give us? Well, first, you get way higher accuracy, spotting things the human eye might miss. Second, you get a huge boost in efficiency, no more unnecessary biopsies, saving time and stress. And most importantly, you get truly personalized medicine. We're finally moving beyond those two big buckets to treat the individual, not just their label. We are standing right at the very beginning of this new era of augmented medicine. By pairing the sheer power of AI computation with human wisdom and experience, we're starting to decode the endocrine system. So, the question I want to leave you with is this: what's next? What other mysteries of the human body are just waiting for us to solve?